Hi everyone, my name's Gavin Henry and I'm here to talk to you today about my open source project called SentryPeer. So here's the obligatory who am I slide. I'm Gavin Henry, 43, married, one son called Ben who's really disabled and has helped drive all of this of where I am today. I'm the founder of SureVoIP, which is a voice over IP internet service provider, which I created in 2010. And from 2006 until 2010, I was a VoIP consultant doing FreePBX and Asterix, but wanted to move up the food chain. A really big telco, great bunch of guys, girls called TelcoSwitch, acquired SureVoIP from me in July this year. So I'm now the CIO of TelcoSwitch. My passion is software engineering. I class myself as a software engineer. And I'm also a volunteer podcast host for Software Engineering Radio, which, depending on where you look, is either #1 or #2 ranking for software engineering podcasts in the world. And that's brilliant. You get to speak to anyone you want about sort of different topics that obviously have to get them approved by the editor, but some great folks. Anyway, on to SentryPeer. So what is SentryPeer? It's an idea, something that I've thought about for a while. The name comes from Sentry as in security, peer for peer-to-peer. I spent a lot of time on Wikipedia looking at the words security and coming up with that. Basically a 2-syllable first word and 1-syllable second word. It's a side project, so I'm doing this on my own time for fun. It's really challenging. I came up with the idea, I think, August last year. And bought the domain names, registered a trademark, and just went from there. I think we're all probably guilty of owning too many domain names, but there you go. So it's a work in progress. It's all developed in public through GitHub. So you can see there, you can click, you can start, you can watch it, you can open an issue with some ideas, and go from there. It's a fundamentally for fraud protection tool, a fraud protection tool. With the primary goal of collecting IP addresses of bad actors, i.e. people that want to do bad things with VoIP, and also let them try to make phone calls and harvest the phone numbers they are calling as well. So this is generally called a honeypot, where you put something out on the internet to harvest things. Different types out there. There's quite a few open source projects out there that do SIP and some other sort of free services. But they all seem to be run by a company or a person, and you don't own the data and you can't see what's going on from a security point of view. So I wanted to do this so everything is done in the open, from the project to the code to the data that you collect. And the plan is to have various agents for using that data, a web GUI, an API, and some other things I'll touch on in a minute. And really, it's a learning project for me. I've been wanting to do some network programming for a long time, and I think this is a really good opportunity to scratch that itch. So why is it different? Like I've already said, the whole thing is open source, GPL version 2 or 3, developed from the start in the open. You own the data, so when the bad actor information comes through, the IP address and phone number, it's there into an SQLite database, so you can do what you want with it. The plan is that ideally, you'd want to share that data so we can crowdsource this data intelligence to be used for all of us in the VoIP world and ecosystem, whether you're running your own phone system at home or you're an operator. I think we can kind of instantly block this type of stuff if it's done correctly. So you can opt in to share that data or not. You can run it yourself and just keep it there. But the library that I'm looking to develop, which comes from the BitTorrent world, is called Tit for Tat, which is basically an algorithm they have. Depending on if you're sharing data with someone else, they'll give you some data as well. So I think it's going to be another little open source project I create. So the idea there being, if you send me some of the IP addresses and phone numbers you've collected, I'll give you some of mine. There's all sorts of nice problems to solve about poisoning those things. How do I prove you are who you say you are? All these things that I've sort of come across over the years doing APIs, OAuth 2, some of the people I speak to. And that's where the peer-to-peer comes from, is sharing that data with other peers and getting it from other peers. The agents that I'm looking to create, I'll touch on shortly, but that basically is a SIP agent. So you could run this either all in one or separately. That will query the data you've collected and return a 404 or 302 to acknowledge whether it's seen that number before and your SIP traffic should just go to the default place, or it should, pay attention to that status code and not allow that number through. So you'll run all this yourself. So it's on network, it's fast, it's quick, it's not a full, 50, 100 millisecond round trip onto someone else's network, creating a single point of failure. Excuse me. You can run this yourself. Just checking that's all recording. And the information is there for you to do with different topologies that I'll touch on. But ultimately, the goal is that you can see and run all this yourself. So on to the interesting bits, the technology. A lot of my time was spent, I think, as we all do as software architects, engineers, developers, programmers, in analysis paralysis. So when you become proficient at software, the language that you're in, you can become a master in that programming language, but by and large, the design patterns, the techniques, things like continuous integration, deployment, how you do things, the language is kind of a detail. But for me, I've always wanted to do a meaty project in C, learn networking from scratch in C, and kind of emulate all the software that's helped me get to where I am today, in the open source world. Things like OpenLDAP, FreeSwitch, OpenSIP, Scammer Elio, Postgres, all these ones that are all written in C for a reason. And I think, C is fantastic. If you look at the Trove top language list, it's always there in the top, 5 at least, or 1 or 2. It's got the longevity that I'm after for a project like this. The build tools are all there. I spent a lot of time umming and ahhing between Elixir, Go, Rust, mainly because I wanted to learn those, and they all bring their own different things. But I'm lucky because I'll get to use those types of things in my day job, so I don't need to pick them for this project. But you have to make a decision to move forward. So for me, I knew it was going to be C, but I just needed to have a look around to see if I should be that crazy or not. Then the next step is, looking at the libraries to use. Go, Rust, and Elixir all have certain levels of maturity in their SIP stacks, whereas LibOSIP has been around since 2000s. It's a GNU project, it's fully out there and deployed, and it's very complete for me. So I had to go with that, and that's working. I'll show you a demo after this. Like the Rust SIP stack, there's one on the crates.io that's a bit incomplete. And also thinking from long term, if you look at something like curl, that's now 25 years old. How many frameworks have been and gone in those 25 years? Rust is 5 years old. Is it going to be here in 5? They're all backed by, well, a lot of them are backed by commercial companies where C has got a standard and everything that you use day to day on your Linux type of desktop or Mac, that's got C underneath. So that's where we were. Because I want this to be all self-contained and potentially running little devices, C is great for that. SQLite, is the biggest deployed software in the world, so that's a safe bet to put the data in. LMDB, you can look at some of these technologies on the podcast list I've done for Software Engineering Radio. LMDB is like the lowest level, fastest key value store in the world. So I'm looking just to put the IP address and phone number dialed in there as a sort of key value thing. So it's as quick as it can be in C with JSON out with a network HTTP server done from scratch, but referencing what's out there with SSL as well. So the standard bits of taking in a network request, whether it's UDP, which is what it is at the moment, but I want to have TCP and TLS in there because that is a bit of data that I want from a sort of intelligence point of view to see where the exploit attempts are coming through. Well, they're not exploits, but you know what I mean. They're trying to probe things, whether it comes from TLS, UDP, or TCP. That's the next step is those types of servers. The API and the web GUI are all kind of standard things. A lot of open source projects don't go for a web GUI, but I want to present that data nicely, so I'm going to go for that. But the tricky bit is the peer-to-peer part. So I've spent a lot of time looking at the different libraries out there. ZeroMQ is one of my favorite sort of sockets on steroids, I call it. But there is another project that they created called Zyre for LAN-based, proximity-based peer-to-peer. I've been speaking to those guys, and they had agreed that there's some interesting challenges to try and do peer-to-peer over the WAN. Mainly the whole discovery part and network topology. So part of the decision I need to make, which I think I made already, is running the nodes on public IPs or behind that. And I really wanted to not have some fixed, stable points where you can bootstrap these systems. Because when this fires up, it needs to know who to go and speak to find out where the other peers are, or broadcast on the local network to try and discover that. So your usual discovery mechanisms that you'd see in things like Kubernetes and all that works fine on the one network, but across the WAN it's difficult. So I think I've made a decision to run like a bootstrap.sentrypeer.org, which is currently on a free Oracle virtual machine, which will have a few nodes that you can connect to, and then the rest will happen from there. But that's going to be a target for bad actors to try and knock out, so we'll have to think about that. So yeah, there's some very interesting problems to solve, which is going to be enjoyable. So there's a web GUI, like I said, just to display some nice data. I've had the logo donated and created for us, and the theme and the web GUI. It's just a case of plumbing those in. That's really just to display some intelligence. The REST API is just going to be GET-based, like the web GUI, so it can be as fast as possible and just give you a big chunk of IPs. But because the data will live in SQLite, you can actually connect to that with any programming language that you want, to do your own thing. Excuse me. But we'll see how that goes. The library another library that I contribute to is a database wrapper that allows you to write to Postgres, MySQL, as long as the schemas are correct. So if other people want to not use SQLite and rely on something outside the node, that's something that can be discussed. And the two main endpoints I want to create to consume this data is a BGP server and a SIP proxy endpoint. So BGP would be when an IP comes in and it's trying to do something, it gets distributed into your BGP network as a network operator and blackholed straight away at the core. So those of us that run a network, we don't need to do anything clever on the application stack. It just goes in and it's dropped. Obviously, we'll put some intelligence in there to not block your own ranges and make sure they're small ranges, but we'll see how that goes. And the SIP endpoint is just to have on network to dip before your call to check whether it's a phone number that's been spotted before. And that will give you a very early notification of, one of your customers has been exploited or something. And there's some other feeds we can do. CG rates is a big project that I've used. We could feed a bad destination list into things like that. There's loads of options once we've got the data. But this is what I want to do at this point. An interesting one is going to be network topology. I've already touched on how we bootstrap peer-to-peer networks. You need somewhere to go, just like when you download a torrent file. You're downloading that .torrent or .magnet thing, and it's got a list of folk to go and contact to get going. So that's something we, as in me, will be playing with. So you don't need to run it on your own LAN. You could put it somewhere in the cloud. You could opt to only take the data and share it out, not use it. You could opt to import data from other peers, if you share data with them. Like I touched on before, the tip for tat library, there's some thinking I need to do about how we prove that you don't poison that and put in wrong phone numbers, and how we know who you say you are. But a lot of these problems have been solved already in other peer-to-peer libraries, so it's just a case of finding the right one, I think. So various configuration options for how to set this up. Is a plan with a configuration file, or configuration on the fly. It's been quite tricky to talk about this because it's all an idea. I've done a prototype which I can show some of the findings. I've started the actual project, so we are running a UDP server on port 5060. It will take in SIP, parse it, and then move that into the bad actor structure, ready to go in the database. So I'm just plugging in SQLite at the moment, and then I'll move on to the peer-to-peer. But when do you talk about things? It's just kind of cool being at a tech conference talking about this stuff that you like to do. So bear with me. So obviously, you want to validate what you're thinking without spending a lot of time. My normal language is Perl. The MetaCPAN sort of packaging system they've got has got so many modules for everything you could ever dream of. So NetSIP is a SIP proxy system with registration, off the shelf, ready to rock. So pretty much once I decided to do a prototype, which I think you all should, it's in the GitHub repo, so it's all there. You can see it and install it, and it's tested and continuously integrated on with GitHub Actions, like all the C code is. Fired up that, listens on 5060, takes in the data, scoops out the phone number and the different types of SIP methods, and sticks it into SQLite. So fired that up, opened up port 5060 on my home IP Juniper router that I've got, fancy one. Went for lunch, and within 20 minutes just came back, checked, and options packets are coming in on a brand new IP straight away. So that was a learning experience for me, just to actually validate that this is all out there. So then obviously you can see the options here, and then the register. The prototype allows you to register with any password. So you can obviously, if they're doing user agent stuff, a lot of them need to register first on their side for them to make an outbound call. So as we can see on the next screen, the invites come flooding in, and it was just, the screen was piling past of all these different numbers. You can see all the different types of formats they're trying to get through dial plans and things. And at the end of the screen, my prototype was just dying. It couldn't keep up. So it was good validation that it worked, but it needs to be faster. But the interesting bit was that once they saw it was starting to croak, the invites throttled back to 1 per second as they were trying them slowly. So there's a lot of clever stuff behind all this, because they make a lot of money with calling their own phone numbers. So I think it'd be really interesting to see, sharing this data, seeing what other people have got, and how it's all done, and keeping up with it. So here's the mock-up for the web GUI. If you're Googling SIP honeypots, you'll probably find this screen online. There's a nice guy that I contacted and asked if I could reference, not steal his design, but reference it for this open source project. And kindly he said, yeah, go for it. I like the sound of the project. You can make it look a little bit like mine. So the colors aren't the same. This was donated, and you can see it in the web GUI folder in GitHub, Bootstrap 5. And the SentryPeer logo and color scheme was done by David Miller. He does a lot of Bootstrap stuff and some work for us. He donated it. So I'm still looking to have some type of peer-to-peer bit around the peer word on the logo, but we'll get there. But I think it's pretty amazing. So that's what the sort of read-only GUI is going to look like to present that data. And this design would be this doesn't have to be on the node getting the data, but I'm designing it so it's all just a simple binary. It's small. It can run because it can see it'll be highly portable. That's one of the points. You can do it anywhere. So that's pretty much it. Special thanks to David for the logo and the GUI and the color scheme. We've got a Twitter account where you can send things. If you would like to watch the project and star it, you can see me doing my commits, every other evening. Got a website which is basically the README of the GitHub project. So what I'll do now is just a little demo. If I can bring this over. So this is the node that runs the Bootstrap thing, which isn't there yet. So if I just go into the SentryPeer thing, make clean to show it works, if I run that, that's it just listening, D for debug mode. I haven't done long options yet. And if I send an invite in, so here's one without a number, just like an options packet. So I'm not responding to the packets yet, but if you look here, you can see it's come in, that's the packet length, it's received, here's a timestamp in nanoseconds, it's incrementing there, and this is ultimately what we're pulling out of it. The source IP, there's no number, the options type, the transport, behind the scenes it's creating a timestamp to log that, and we're also logging the full SIP packet. So when we go into the API or the web GUI, probably the web GUI because it'll be too much on the API, you can see some more information. So I'm just kind of interested in the number, the IP, the transport method, and the SIP method, and the user agent at the moment. If other people want more, we can expand that data structure. So if I now just give that a bit of space, you can see it. If I now do it with a number, you'll see the username part we're just scooping out, put that in. That's coming through. It's pulled out the number with the libosip2 library. So that'll go into the database. You can query that through the API or through a SIP invite to the agent, which is coming, and that will, be able to tell you whether it's seen it before. So what I was thinking to do there was, if it hasn't seen it before, the SIP proxy will just return your default destination. If it has seen it before, it'll do like a found or something like that. I'll figure that out. That's pretty much the progress so far. It looks like a little, but it's quite a lot after prototype stage and all the choosing different things. Oops. So yeah, start the project, like it, open an issue with some feature requests, get them in the system, and have fun, watching a project starting from scratch and, progressing. So move forwards. Thank you very much. That's Gavin for SentryPeer.